Hello, welcome to Module 4 of this series of videos in Introduction to Business Statistics. So as I was brainstorming, what do I want to say in this introductory video? How do I want to present this topic that we're looking at here? This one is now Intro to Probability. I started to find myself sounding a lot like I think any academic or specialist in pretty well any field. If you talk to somebody who studies biology, they'll tell you, I really think that everybody should have some basic understanding of biology. Or a psychologist will say the same thing about psychology. Or I'm an economist. I think, man, the world would be a better place if everybody understood some basic economic theory. Well, as I'm trying to put together what do I want to say in this introduction to probability video, I'm starting to think the same thing about probability. Everybody should have a basic understanding of probability and probability theory. It has applications in every aspect of life. Whether we're looking at complex risk management strategies, or we're looking at project management, or you're a gambler and you're going to the casino and you're playing cards. It seems to show up everywhere. So hopefully in this module we'll cover some of the basics that not only will they hopefully facilitate further study and understanding probabilities as we go through the course, but I hope that it will maybe demonstrate just how widely applicable understanding probabilities can be. So I can continue to babble on about this. Let's just get into just what is it we're going to do. Okay, so what does it mean, probability? Probability is really talking about the likelihood of something happening. So a likelihood of an event. Now, you've probably been exposed to probabilities at some point or some context or what have you. So maybe we have some basic understanding of probabilities and how they work. They generally range from a value of 0 to a value of 1. 0.5, of course, is in the middle. So a probability of 0.5, if an event has a probability of 0.5, it basically means that it's equally likely and unlikely to occur. So the chances of something happening and not happening are the same. As we approach 0, this is going to be something that is less likely to occur, or as we approach 1, this is more likely to occur. So, for example, we can take something as mundane as, let's say, flipping a coin. This is, everybody who teaches statistics and probability. Flipping the coin is the first thing that you go to. So flipping the coin, you can either be heads or you can be tails. Now, assuming that the coin is what we call a fair coin, it's got both of these sides and it's, properly weighted and constructed and everything. Well, we say there's a 50-50 chance of getting heads or tails. What that means is that there's we're sitting at 0.5. We're right here. There's an equal chance of getting a heads as there is not getting a heads, which means, of course, in this case, flipping a tails. So we're exactly the same regardless. Now we can go a little bit further and we can we can roll a dice. So if we roll a dice, we have 6 outcomes. 1, 2, 3, 4, 5, 6. What's the probability of any one of these coming up? So what's the probability of rolling a 3? Well, the only way I can roll a 3, there's only one die, so the only way I can roll a 3 is if it's in fact a 3. There's no combinations here, it's just one dice. So there's 1 out of those 6 possible outcomes. So there's a 1 in 6 chance of rolling a 3, just like there's a 1 in 6 chance of rolling a 4. So what this means, this is the probability of an event occurring. What we'll then talk about also is the complement of that event occurring. And the complement would just be, in this case, 1 minus the probability of that event occurring. And so this would be 5, 6. So here we're looking at a number, the probability of an event occurring is somewhere down here, 1/6. And so the probability of that event occurring, rolling a 3, not very likely. its complement means the probability of not rolling a 3 much more likely. Now we're over here at 5, 6. So, okay, so rolling a dice and flipping coins, not really all that stimulating. But as we progress through the material, it will become, I hope it will become much more interesting, because this is the groundwork for talking about different probability distributions that relate to or that correspond with different types of events, whether we're looking at discrete or whether we're looking at continuous variables. These terms, remember, are the terms that we talked about in Module 1. So, in Module 4, what we're going to be looking at are really defining probabilities. Really counting is even an important part of this chapter. Now you might think, if we look at these two little experiments that I did here, there's 2 possible outcomes here, there's 6 possible outcomes here. Okay, that's pretty straightforward. We can take that a step further, and let's say you're opening up a pizzeria and you want to sell pizza, and you have 5 ingredients for your pizza. Okay, so how many different 2-topping pizzas can you make? How many different 3-topping pizzas can you make? How many different 4-topping pizzas are you making? Okay, so it's a simple example of the counting rules, and we'll talk about these things called combinations and permutations, different way of counting, different combinations of things occurring, and we need that in order to calculate probabilities. We'll also look at some of the basic arithmetic of probabilities, so we'll look at the addition law, because adding probabilities, it's dependent on whether or not what we're adding together, are they mutually exclusive or not. To say something is mutually exclusive, or to say that these 2 probabilities that we want to add together, to say that they're mutually exclusive, means that if one event occurs, the other event cannot occur. So, if I'm calculating the probability of, or adding up probabilities of cars crossing over a bridge and trucks crossing over a bridge, if a car crosses the bridge, it can't also be a truck, right? So it can't be both a car and a truck at the same time. So those 2 things are mutually exclusive. And so whether or not they're exclusive, that will affect the arithmetic in adding probabilities together. Similarly, we'll look at the multiplication law, and it's similar. We understand multiplying things together, but in dealing with probabilities, the way that we do this depends on whether or not events are independent or not. So does one event occurring have any impact on the probability of something else occurring? So for example, rolling that die. Every time I roll the die, each probability is independent of what was rolled prior to that. If I roll a 4, okay, if I roll the dice again, the fact that I rolled a 4 just before, it has no impact on the probability of getting a 4 again or getting a 6 or what have you. Those events, rolling a die, totally independent. Drawing cards out of a deck of cards, on the other hand, well, that's not independent. Because if I have a deck of cards, and it's 52 cards in the deck, I can calculate what's the probability that I draw an ace out of that deck of cards. Well, I know that there are 4 aces in that deck of cards, so the probability of drawing an ace, that's going to be 4 out of 52. That will give me the probability of drawing an ace. So I draw a card. What if that card's not an ace? So I draw 3 or 10 or anything else. So I don't get an ace, so no ace. Well, how does that change the probability of getting an ace if I draw another card? Well, now if I've taken 1 card out of that deck, now there's only 51 cards left in that deck, and maybe there's still 4 aces because I haven't drawn one yet. So the probability now of getting an ace is going to be 4 out of 51. So this is just maybe to whet your palate, to get you interested, hopefully, in appreciating some of the subtleties and maybe some of the complexities in dealing with probabilities. So this is what we'll go through in this exercise. Not so much getting into some more interesting type of problems. We'll hold off on that until we get into some of the specific probability distributions that are required to address problems like this. This is just going to be covering some of the basic fundamental arithmetic. So we'll be looking primarily in this module at how do we deal with probabilities under these different scenarios. Okay, so hopefully this will be of interest to you. Again, this is a starting point. It's absolutely important that we understand the nature of probabilities before we can go through into some of the more complex problems that we will see. So we'll get through Module 4. Hopefully it's interesting. I don't mean to sound like it's going to be dry or boring, but it's an important aspect of understanding statistics. Okay, so let's get into our first problems. Thanks for watching.